Hello dear students. So in the last part of the video, that is in part 7, we have covered exercise 10.4. Okay, and students, in this part of the video we are going to see some theorems, and on the basis of these theorems exercise 10.5 is based upon. Okay, so firstly let us see the theorem 8. Okay, and what is the statement of theorem 8? The statement is the angle subtended by an arc at the center is double the angle subtended by it any point on the remaining part of the circle. Okay, so what is the meaning of this statement, students? See, if there is a circle, okay, suppose this is the circle, okay, and in this circle there is an arc. Suppose this arc is AB, okay, this is an arc AB, okay, and this arc forms an angle at the center, okay, and this arc, okay, by the same arc one angle is formed at any point on the remaining part of the circle. Okay, this is arc, so the remaining part of the circle is this. Okay, so by this arc one angle is formed at the center of the circle and one angle is formed at any point of the circle. Suppose this point is P. Okay, this point is P. So now, according to the statement of the theorem, this angle will be the double of this angle. Means, suppose this angle is X, then you have to prove that this angle is 2x. Okay, this result is very important, students. What is the result? That by the same arc, okay, the angle formed at the center is twice the angle formed at any point on the remaining part of the circle. Means, suppose if this angle is, suppose this angle is 20 degree, then what will be the measure of this angle? It will be twice of 20, means it will be 40 degree. Okay, if this angle is 10 degree, then this angle will be twice of that, means 20 degree. Okay, like this. Okay, this result helps us to solve the question. Okay, again you have to understand that angle formed by any arc in the circle is twice the angle formed at the same arc by remaining part of the circle. Okay, suppose in the question it is given that it is 100 degree, this angle is 100 degree, then what will be the measure of this angle? You can say, if you are saying that this angle is twice of this angle, then at the same time you can also say that this angle is half of this angle. Okay, means if it is 2x, then it is x, means this angle is half of this angle. So if it is 100 degree, then you can say that it is 50 degree. Okay, students, so this result is very important. Now the question is how we will prove that this angle is twice than this angle. Okay, so for to prove this, total 3 cases are possible, students. One, see, I have told you that arcs are of 3 types. Okay, this is the case of minor arc, and the second case will be of semicircle. Means if the arc is equal to the semicircle, okay, then that case will be the second case. And the third case is what? The third case is based upon the major arc. Okay, so here we will see only the case of minor arc. Okay, and you will try to yourself to prove this theorem for semicircle and for major arc. Okay, now students, see how I am going to prove it. Firstly, we will see that what is given. What is given? So in the given part we will write that a circle C O comma R, okay, in which arc AB is there, okay, in which arc AB is there, and angle formed by arc AB at the center is angle AOB, and angle formed by AB arc at point P, okay. This point P, okay, this point P can be in any part of the arc BA, okay, because in the question it is written that a remaining part of the circle. So if in a circle you extract this part AB, then what is left? This BA arc, okay. So the angle formed by arc AB at point P is angle APB. Okay, students. Now what is to prove? What is to prove here? We have to prove that angle AOB is equal to 2 times angle APB. This we have to prove, okay. But before that we have to do some construction, okay. And what construction we will do? Okay, we join this PO, okay. Just draw PO and extend it to Q, okay. Suppose this point is Q. What I have done in the construction part, I have joined this PO and extended to point Q, okay. So this is PQ is a straight line, okay students. This PQ is what? This PQ is a straight line. Now coming to the proof part, okay. I have told you students that this case is for minor arc, okay, and by the help of this you will do the case of semicircle and the case of major arc, okay. Now students, you know that this is the circle of center O and radius R, okay. Let us make a figure which is larger, okay, because if the figure is smaller then you will face the problem to see. So let us make a larger circle, okay, and in this larger circle this is A and this is arc AB, okay, and by this arc at the center one angle is formed, and at point P one angle is formed, okay. Now students, in the construction part what I have done, I have joined this PO and extend it to point Q. This is O and this is point P. Students, I have told you that this is the circle of center O and radius R. So you can see that this is the radius, OP is the radius, and here OB is the radius, and here OA is the radius, okay. So students, we know that if in a triangle two sides are equal, then the angles opposite to them, the angles will also be equal, okay. So here in this triangle, and triangle PAO, okay, this is the radius, means the angle opposite to them, okay, if it is angle 1 then it will also be angle 1, okay. In the same manner, in this triangle also, triangle POB, this is the radius R, this is the radius R, so if it is angle 2 then it will also be angle 2. Are you getting this point? Okay, we have studied in the chapter triangle that if in a triangle two sides are equal, then the angles opposite to them, that angle will also be equal. So here their radii are equal, then if it is angle 1, then it will also be 1, and if it is angle 2, then it will also be angle 2. Okay, so how we'll write this? We'll write that in triangle AOP, okay, side AO is equal to side OP, okay, and both are equal to radius. So this will imply that angle PAO is equal to angle APO, and suppose it is angle 1. Okay, we have supposed that it is angle 1. In triangle POB, in the same manner, okay, OP is equal to OB, and they are equal to each other. So angle OBP is equal to angle OPB, okay, and say it is angle 2. Okay, now students, for this triangle APO, okay, we have studied the concept of exterior angle. Suppose in this triangle this side is extended, then this angle will be equal to the sum of these two angles. If it is 1, it is 2, and it is 4. So what we have studied, exterior angle property, that angle 4 is equal to angle 1 plus angle 2. This we have studied exterior angle property. Okay, so here in this case also, if we will find the angle AOQ, okay, see, for triangle APO, the side PO is extended to Q, okay, then this angle AOQ will be the exterior angle for this triangle. Okay, so this angle will be equal to the sum of these two angles. So here we'll write, for triangle APO, angle AOQ is equal to angle, see, angle this plus angle this, so both are equal to angle 1, so angle 1 plus angle 1. Okay, and how it is done? By exterior angle property, Okay, so here we can write that angle AOQ is equal to 2 into angle 1. Angle 1 plus angle 1, 2 angle 1. Okay, suppose it is equation number 1. Now, for triangle BPO, angle BOQ is equal to angle 2 plus angle 2. Okay, see, this angle will be the exterior angle for this triangle BPO. Okay, so angle BOQ is equal to angle 2 plus angle 2, and how I have written this? By exterior angle property, Okay, so angle BOQ will be 2 into angle 2. Suppose it is equation number 2. Now students, what we'll do, we'll add these two equations. Okay, adding first and second. Okay, so if we add first and second, then what we'll get? Angle AOQ, left hand side will be added to the left hand side, angle AOQ plus angle BOQ, and right hand side will be added to right hand side, means 2 into angle 1 plus 2 into angle 2. Now angle AOQ plus angle BOQ, okay, if you will add this angle and this angle, then you will get what? The whole angle, angle AOB. The whole angle, angle AOB. And if you will take 2 as common, then angle 1 plus angle 2. Okay. If you will add these two angles, angle 1 plus angle 2, then what you will get? The angle APB. Okay, angle 1 plus angle 2. Okay, so here you can write that angle AOB is equal to 2 into angle 1 plus angle 2 will be what? Angle APB. Okay, and here you have to write that angle 1 plus angle 2 is equal to angle APB. Okay students, so this is to prove here that the angle formed by any arc at the center is double the angle formed by the same arc at the remaining part of the circle. Okay, so this is the proof of this theorem, and this is the case of minor arc. This AB, this arc AB we have taken, it is minor arc. Okay, so this is the case of minor arc, and only figure will be changed, student. Okay, and rest of the things will be same, means the proof of semicircle and the proof of semicircle and the proof of for major arc, the process is same. Okay, each and every step will be same. Okay, only the changing will be in the figure. Okay, are you getting my point? Okay, so this is how we can prove that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay students, so now you can pause the video and note it down, the proof of this theorem. Now students, coming to the next theorem, theorem number 9, and the statement of the theorem is what? Angles in the same segment of a circle are equal. Okay, so this result is also very important, students, that if the angles formed in the same segment of the circle, then that angles will be equal. Okay, how we can make the figure of this statement? Okay, suppose this is a circle. Okay, and we have to show that angles in the same segment. So we know that if it is an arc AB, okay, so if we draw a line like this, okay, then this is the one segment and this is the other segment. Okay, so if the angle is formed by this arc, okay, in the same segments, like suppose this angle is, okay, and one angle is formed at point this. Suppose this is point Q, this is point P. Okay, so we have to show here that these angles are equal, means angle APB is equal to angle AQB. Okay, so we have to show this. So how we will show it, students? How we will show it? Let us see. Suppose, students, that here this is the center of the circle. Okay, not the intersection point. Okay, so if this is the center of the circle, then at the center, okay, at the center it is forming some angle. Okay, this is the point O and this is the angle formed at the center. Okay, so students, how will prove it? Firstly, let us see in the given part. In the given part, what we'll write? In the given part, we'll write that a circle C O comma R. Okay, a circle is there of center O and radius R. Okay, and angles formed in the same segment are angle APB and angle AQB. Okay, these angles are in the same segment. Okay, now to prove, here you can also write that by an arc AB. Okay, by an arc AB. To prove, what is to prove here? We have to show that angle APB is equal to angle AQB. Okay, we have to show that these two angles are equal. Now, how will prove it, students? So for this, firstly, let us do some construction. Okay, and what construction will I do? Okay, just join AO and BO. So here we have joined AO and BO. Okay, this you have to join AO and BO. AO and BO. Okay. So angle formed at the center. So angle formed at center will be angle AOB. Okay, angle formed at the center will be angle AOB. Now coming to the proof part, how will prove it? Students, just now in the last theorem we have studied that angle formed, okay, this dotted line I have made to make you understand. Okay, there's no need of making this chord AB. Okay, so what I am telling you, I was telling you that just now we have studied that angle formed at the center is double the angle formed by the same arc in the remaining part of the circle. Okay, this result we have studied, just now we have studied. So by that theorem we can write the angle AOB is equal to 2 times angle APB, and also we can write, see, if this angle is x, then this will also be 2x. Okay, and this is for the same, if this angle is x, then this will also be 2x. Okay, so means by this arc AB, the angle formed at the center will be double of this angle as well as double of this angle also. So here we can write that angle AOB is equal to 2 times angle AQB also. AQB also. Okay. What is the reason behind it? The reason is the statement of the previous theorem. Okay, that angle formed at the center is double the angle formed in the remaining part of the circle. Okay, so this is the reason. Now students, if you will suppose that this is equation 1 and this is equation 2. Okay, so from 1 and 2 you can see the left hand sides of these equations. The left hand sides of these equations are equal, means here also it is angle AOB and here also it is angle AOB. So from 1 and 2 we can say that their right hand sides should also be equal, means 2 into angle APB will be equal to 2 into angle AQB. Okay, now this 2 and 2 will be cancelled out. What is left? Angle APB is equal to angle AQB. So students, this was to prove here in this theorem that angles in the same segment are equal. Okay, so this is how we can prove. We can relate these two angles with the angle formed at the center. Okay, and we know that it is the twice of this angle. Now how we can apply this question in solving the questions? Okay, how we can apply this theorem in solving the questions? Suppose in any question it is given that it is 30 degree. Okay, and you have to find this angle and this angle. So we know that if it is 30, then at the center it will be 60 degree. I am just giving you an example. Okay, the proof of the theorem is completed here. I am just giving you an example that how to solve the questions of circle. Okay, so if it is 30 degree and if it is asked that what will be the angle at the center, then it will be 60 degree. And what will be this angle? So if it is 30, then this will also be equal to 30 degree, because they are the angles in the same segment. So angles in the same segment are equal. Okay, this is how we will apply this theorem in solving the questions. Now students, you can just note down the proof of this theorem. Just pause the video and note it down. Now students, coming to the next topic, and the next topic is cyclic quadrilateral. But before that, I want to make you clear that the theorem 10, okay, the theorem 10 of NCERT is now removed from your syllabus. Okay, so after the theorem 9, we'll see the topic cyclic quadrilateral. Okay, theorem 10 is now removed from your syllabus for the session 2020-21. Okay, so what is the definition? What is a cyclic quadrilateral? Okay, how we can define a cyclic quadrilateral? So we can give the definition that a quadrilateral ABCD is called cyclic if all the four vertices of it lie on a circle. Okay, means suppose here is a quadrilateral ABCD. Okay, this is the quadrilateral ABCD. So when this quadrilateral will be known as cyclic quadrilateral if the vertices of this quadrilateral, means the vertex A, vertex B, vertex C and vertex D, if all the vertices of this quadrilateral lie on a circle, then this quadrilateral will be known as cyclic quadrilateral. Okay, are you getting my point? If any one of the vertex will not lie on this, suppose this is like this. Okay, if any one of the vertex will not lie on the circle, then this quadrilateral will not be cyclic. The condition is only that its all vertices should lie on a circle. Okay, in this case only this quadrilateral ABCD is known as cyclic. Okay, so firstly you should note down that what is the definition of cyclic quadrilateral. So just note it down. A quadrilateral ABCD is called cyclic if all the four vertices of it lie on a circle. Friends, coming to the properties of cyclic quadrilateral, and the properties of cyclic quadrilateral we'll see in the forms of theorems. Okay, so the first property of cyclic quadrilateral, that is theorem number 11. The theorem is the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. Okay, in the simple language we can say that the opposite angles of a cyclic quadrilateral is 180 degree. Okay, but here you have to prove it also. Okay, so suppose this is a cyclic quadrilateral ABCD. Okay, this is a cyclic quadrilateral ABCD. So according to the statement, what will be there? That angle A plus angle C, it is equal to 180 degree. and angle B plus angle D, it is equal to 180 degree. Okay. In other words, we can also say that the sum of the opposite angles of a cyclic quadrilateral is supplementary. Okay, supplementary. Okay, either you can use the word that is it is equal to 180 degree, or you can say that it is supplementary. Okay, now we have to prove, students. So firstly, we'll write that what is given here. So what is given? We can write in the given that a circle, okay, or you can directly write that a cyclic quadrilateral ABCD. Okay, what is to prove? We have to prove that angle A plus angle C is equal to 180 degree and angle B plus angle D is equal to 180 degree. Okay, how will prove it, students? So firstly, prove it. To prove this theorem, we have to do some construction. And what construction we will do? Just join this AC, okay, and BD. We have to join this AC and BD. Okay, so in the construction we will write that join AC and BD. So students, when we will join the AC and BD, okay, now coming to the proof part, students, if we consider the chord AB, okay, for this chord AB, or you can say that for arc AB, see, in the previous theorem, okay, I have told you that angles in the same segment are equal. So if you are talking about the arc AB, okay, then you can say that this angle is equal to this angle. Okay, so for arc AB, angle ADD is equal to angle ACD. Okay, and what reason we'll write? We'll write that angles in the same segment. Angles in the same segment. Okay, and suppose it is equation number 1. Now students, if you will consider the arc DA, just consider this arc DA, then you can say that for arc DA, okay, arc DA, again you can see that for this arc, students, angles in the same segment will be this angle and this angle. Okay, for this arc DA, angles in the same segment will be this angle and this angle, means angle DCA, or you can write that angle ACD, okay, DCA or ACD both are same, okay, is equal to the angle ABD, is equal to the angle ABD. This is the second equation, and the reason is same, that angles in the same segment. Okay, angles in the same segment, the reason is same. Now students, here you can see that this angle is equal to this angle and this angle is equal to this angle. Okay, now if we add these two equations, adding the equations, adding first and second, so see, angle ADB, students, one thing I am going to change here. Okay, what, that only I am writing this angle ABD in the left hand side and angle ACD in right hand side. It will make no difference in the proof. Okay, just what I have done, that I have shifted this angle ABD in the left hand side and written ACD in the right hand side. Now if we add these two, so angle ADB plus angle ABD, and in the right hand side angle ACB plus angle ACD. Here you can see, students, that angle ACD and angle ACB means this side, right hand side. Okay, so if we add these two angles, then you can write that it is angle C. You can write that these two angles, the sum of these two angles will be alone the angle C. Okay, and here in the left hand side it is angle ADB plus angle ABD, this angle and this angle. Now students, what we'll do here in this step, it is equal to angle C. Okay, see here, for this triangle ADB, okay, this angle is there, this angle is there, and angle A is also there. Okay, for this triangle ADB, this angle plus this angle and plus angle A. So if we want to make this side 180 degree, if we want to make left hand side 180 degree, what should we do, students? What should we do? We have to add this angle A, because this angle is there, this angle is there. What is not there? Angle A is not there. So if we add angle A in the left hand side and also in right hand side, so left hand side will become 180 degree, because we know that the sum of the angles of a triangle is 180 degree. So what I am going to do here, that adding angle A both sides, adding angle A both sides. So if here we will add angle A plus angle ADB plus angle ABD is equal to angle C, and in the right hand side also we have to add angle A. Now students, after this step I am going to write here, see, angle A, this angle, plus angle ADB, okay, this angle, and plus angle ABD, this angle. So we know that the sum of these three angles will be what? 180 degree, because the angles are of the triangle ABD. Okay, so students, the left hand side will become what? 180 degree, and the right hand side is what? Angle A plus angle C. You can see that it is angle A plus angle C, and the left hand side will become what? 180 degree. Okay, how it will become 180 degree? We know that since in triangle ADB, okay, angle A plus angle ADB plus angle ABD is 180 degree. Okay, reason I have written here, this reason I have written here, and after this step we'll write this, that in this triangle the sum of these three angles is 180 degree, so that is why the left hand side becomes 180 degree. So here we can directly say that angle A plus angle C is equal to 180 degree. Okay, and similarly we can prove, we can show, or we can prove that angle B plus angle D is 180 degree. Okay, similarly we can show that angle B plus angle D is equal to 180 degree, or one other method you are having, you know that the sum of the angles of quadrilateral is 360 degree, so you can subtract this equation, okay, this angle A plus angle C in 360 degrees, so you will get what? Angle B plus angle D is equal to 180 degree. Okay, So students, this is the proof of the first property of cyclic quadrilateral, that the opposite angles of cyclic quadrilateral is 180 degree or they are supplementary. Okay. Now students, you can pause the video and note it down, and also it is enough for today. So whatever the properties are left, we will see in the next part of the video. So thank you students.